Here, we have a simple circuit with a battery connected to a switch, current meter, and a light. This is a standard DC battery. A battery usually has a plus and a minus symbol. The plus symbol indicates the positive terminal, and the minus symbol indicates the negative terminal. This shows you the polarity of the battery. It is connected to a wire. I decided to represent this wire as a tube so I can demonstrate the concept of positive charges or electrons flowing through it. This is a current meter, which is reading 0 because this switch is open. That means current can't flow through the wire. The light bulb here is going to represent a conventional old-fashioned incandescent light bulb that doesn't care which way current flows. It's going to light up in either direction. You can also think of this light bulb as a standard resistor. If you follow the wire, it is going back to the negative terminal of the battery, and that completes the circuit. The conventional flow of electricity tells us that positive charges flow from the positive to negative. It is important to recognize that the positive terminal of the battery acts like it's pushing out positive current or positive charges, so current will be flowing clockwise in the circuit. We've connected a basic current meter to our circuit. It has a positive and a negative terminal also. This corresponds to the positive and negative terminal of the battery. You want to connect the positive to positive and negative to negative. The light bulb doesn't care which way current is flowing. It's going to light up either way. Again, the switch is open so no current can flow, and the current meter reads 0 and the light is not on. This will be a complete circuit as soon as I close the switch. And when I do that, the positive terminal of the battery pushes current out in the clockwise direction, and the current meter will read a positive number. Let's just say it's plus 2 amps, and the light will turn on. That means I'll have a complete circuit. We would say I, the symbol for current, equals positive 2 amps. If we drew this circuit in a homework problem, we would say that the current is actually flowing in this direction. We would write I equals plus 2 amps. So what would happen if I connected the battery the other way? Let's take the battery out and rotate it. I'm connecting the positive terminal on the right and the negative terminal on the left. Now, current is going to change directions. The meter will read negative 2 amps. The light still will be on because this light bulb doesn't care which direction current flows. Some lights do have a definite polarity, like an LED, and will only allow electricity to flow in one direction. We can say I still equals 2 amps, but it is flowing counterclockwise in the circuit. It is still coming out of the positive terminal of the battery, but it's going in the opposite direction through the circuit, so the meter will read a negative 2 amps. In electrical engineering, we have all our instruments and equations calibrated to talk about positive charges flowing through a circuit. This is not how electricity actually flows, but it ends up eliminating a lot of the negative signs in our equations, and that is why we stay with this convention. In reality, there is no such thing as positive charges. An electron is the physical carrier of electrical charge. What's creating electricity is the flow of electrons from the negative terminal to the positive terminal of the battery. For demonstration purposes, I have a significantly sized negative charge, even though we know electrons are very, very tiny. Now I'm going to close the switch. Electrons are going to flow out of the negative terminal of the battery in this direction. I'm showing that they're going to flow through the light bulb, which makes it light up. The current meter is going to read a positive number. Again, just for demonstration purposes, let's say a positive 2 amps. Those electrons are coming back and returning to the positive terminal of the battery. The battery does its magic, which actually is a chemical reaction, and the current keeps flowing. So, when we say the current is flowing in this direction, actually, electrons are flowing in the opposite direction. Hopefully, to help solidify the concept, I will show the conventional flow of electricity side by side with the actual flow of electrons. And that is how current flows through a circuit.